Okay, hey guys, it's me again, Arthur. And today I'm going to be talking about most of the components I'm going to need to finally build my robot. So what you can see here is the robot platform from Lynx Motion that I bought over RoboShop. I did come across this platform like 3 years ago, but I thought it's too expensive. And I was thinking about making my own platform, and I did actually put a lot of thought into that and did a lot of research and stuff. But in the end I just got back to actually buying this platform, because it's a very nice platform and it's actually not that expensive, because the most expensive part about the platform were the motors and the encoders, and I have to buy them anyway. So just a metal frame with the Lexan panels that go on the top and on the bottom. That was actually cheaper than I could have made it if I would made it myself, and I just didn't have the time to finally make it. So I just bought the platform. There are some downsides of that, because I can't just fully customize it. It's not fully customizable, because if I would have built it myself, I might have just built it a little bit bigger, but that's alright. I mean, it's a very nice platform. You can adjust the motors, and you know it's going to be working, and yeah, so I just bought that. So what you can see in here are the motors with the encoders. There are 4 motors. Well, now you can just only see 3 because I took one out to show you later. And I already kind of like installed the motor driver board. On top here you can see a relay board that I made myself. That's going to allow me to break the motors, and these two relays here, you can't really see, these ones are taking care of the LiPo batteries. So the Rover can switch itself off if it's not being used, because you don't want to drain your LiPo batteries, because that's really bad for the batteries. So in case I leave the robot on and just leave the house, the robot could actually realize, well, I'm just sitting here not doing anything for like 10 minutes or so, so it's just going to turn itself off. So that's why I need the relays. And it's a sandwich board, so on the bottom here, this is the Rover 5 driver board. It's manufactured by SparkFun, that's why it got the red seal screen. And yeah, so I already connected the motor outputs to the breakboard, and also connected the encoder wires. I kind of like modded the connectors a little bit, but anyway. Yeah, so these ones are the connector wires for the encoders on the motors. And yeah, so this is going to sit in here at the bottom part of my platform later on. And here are going to be sitting 2 batteries for the motors, and another battery is going to sit here for all the 5-volt logic, the electronics and stuff. And there's also going to be a power board in there, but more on that later. So the motors I'm using are these geared motors. They have 291 RPM and are geared for a ratio to 30:1, and they run off 7.2 volts, and I'm using 7.4, so that's quite nice. And the really they're kind of special because they have an encoder shaft on the back. You can't actually really see that here because the encoder is already on there, but here's a picture of it. And yeah, so what this allows me to do is actually fit an encoder onto the back of the motor, and if the motor is turning, the back shaft is turning, so the encoder can actually tell how far the motor is turning. You can actually see when I'm spinning the wheel here that the back shaft is turning, and the encoder that's on there is a 400 count or 400 step encoder, so with 1 revolution of the back shaft encoder you get 400 steps. And you can already see, if I just turn this wheel like a little bit, it's already turning like crazy. So you can imagine, I'm going really fast, I got like, I don't know, like a few thousand steps. So, very precise. Nice. Okay, so let's talk about the power. I already mentioned that I will have different batteries. I'm using LiPo batteries. And the ones you can see here, they are for the logic. So these ones are just 7.4 volt 2-cell LiPo batteries. These ones are 4 amp hours, and there's going to be one of them in the Rover for the logic and stuff, and I'm going to order 2 other batteries for the motors. They're going to be 7.4 volts as well, 2 cell, but they each going to be 8 amp hours, so I got 16 amp hours. Since the motors are actually, they can use up to 3.8 amps at store, so I got 4 of them. So at store they would actually draw 15.2 amps or so. So I do want to have like a good hour of driving, maybe 2 if I don't drive all the time, like operating time. I can't show you the motor batteries right now because I just have to order them, because I'm just ordering them now because I didn't know if I could fit them in there. And they have like a little unusual size, but you will see that in a later video. And I did decide to use separate batteries for the logic and the motors, because I don't want to have any noise of the motors on my logic power line. Yeah, so I'm now just going to talk about the logic power line, because I already showed you the other board. This is a board I designed for the logic on the Rover. It's going to sit in the bottom section as well. So what we have in here, you might have noticed the other relay, and again, this is just to completely electronically disconnect the LiPo battery from the board. So if I switch it off, it's completely electronically disconnected, so I can't ever drain the battery. And also, if the robot detects that the battery is almost empty, it's going to switch itself off, so that's very handy. So the power from the battery goes through the relay into this HRC fast blow fuse. This is just another layer of protection, and through a current sensor, and through a step down regulator, and just basically comes back out again. And here's a LM7805. Yeah, so I'm using that with the transistors to actually control the relay, because that's 5 volts. I did that for various reasons, but I have another video on this board. And yeah, so that's just going to sit in the bottom section of the Rover, like right here. Whoops, that in there. And here are going to be the batteries. So yeah. And the way I designed the power boards, both the one on the Rover 5 driver board and the other power board I just showed you, allows me to actually charge the LiPo batteries while they are in the Rover. So that's very handy, because I don't have to take them out. I don't actually advise you do this on your own project, because it is kind of dangerous, and you have to be very careful with LiPo batteries, because they you can cause quite a lot of damage to them if you don't charge them right, and then they can be quite dangerous. But yeah, I'm just going to leave them in there because I can't take them out all the time, because that would just take too long. And another word on LiPo batteries, like I said, you don't want to drain them, and if you're just starting out, you can use like this low voltage alarms. They are just connected on here, like this. Whoops, yeah, that's right. Yeah, okay, so if you noticed 2 green LEDs here, since this is a 2-cell LiPo battery, and if one of the cells drops under 3.3 volts, it's going to sound an alarm, so you know that the batteries are empty and you have to switch off the Rover. But I will actually probably connect a sensor in here, and I also have the current sensor, so I know how much I used up from the battery, so I can calculate or even measure when it's empty, so I can automatically switch them off. So I don't have to worry about any of that. Okay, so now let's get to the electronic side of things. The main board on my Rover is actually going to be this. This is an Arduino Mega. You've probably seen this before. It's basically an Arduino with just more pins. And on top of that, there's going to be this. This is a proto board. You can already see there are some wires on there. It's basically just a bare board that allows you to access all the pins. That's going to be on there like this. Whoops, I'm not going to do that now, but yeah, it's going to sit on here like this, so I can access all the pins. You can already see the wires that are connected here. I'm going to disconnect them again. Well, I'm just going to desolder them because I found a better way. I was thinking about connecting DC connectors here and then just run ribbon cables off there. But it's just way easier to just take the ribbon cable and wire the pins directly. So yeah. And I'm just going to call this the patch board for now, because I'm going to connect all the different sensors and shields and stuff to here. And yeah, so let's talk about shields. If you know about Arduino, you might have actually heard about shields. So here you can actually see an Arduino Uno. That's one of the basic boards from Arduino. And on there is an MP3 player shield from SparkFun. You can just pop it on there like that, and all the pins are connected. So I am actually using 3 of shields like this on my Rover. The good thing about shields is that you can normally stack them on top of each other, which would work as well fine with all these shields. The problem is that the shields I'm using are actually using most of the same, well, they are using the same pins to connect to the Arduino, so that won't work. So what I'm doing is I actually got these are other proto boards for the Arduino Uno, and I just gonna have some headers that I'll connect to them, and that will allow me to just stack on the shields, and then I'm gonna just wire all the pins I'm using with ribbon cable to the patch board. So I'll just have like 3 of these shields with headers sitting on a board, and I can just pop on the different shields that I want to use. So let's talk about the shields I'm going to use. I already showed you the MP3 player shield. I'm going to use that to play audio files, like sound files, I don't know, if the Rover is starting up or something, or if there's an alarm. And I could also use like a computer voice to put sound files on here that could say like, I don't know, all systems online, or there's been a security breach or something like that. So that's kind of nice. On the other side, I got a voice recognition module, like I showed you before, this one. This is the EasyVR. Well, the main part is actually this little board on here, but this is the shield version for Arduino, so it works great with the Arduino. And this actually allows me to detect voice commands, so I could program this to listen for commands like Rover, move forward for 5 meters, and then the Rover would move forward for 5 meters, or Rover, go into autonomous mode, or Rover, patrol the area. So yeah, that's pretty handy. And last but certainly not least is the GSM shield. So what this shield is, it's pretty much a mobile phone on an Arduino shield. So this is the cellular module on here. There's a little bit of tape on there, but yeah, this is the cellular module. And you just pop a SIM card in there, and that's pretty much a mobile phone. So the Rover will be able to receive calls and receive text, and it's also able to call a phone or even text a phone. So that's pretty handy. So I can get real-time alerts if something goes wrong. Like if it's like patrolling an area and there's security breach, it could actually send me an SMS saying there's security breach in sector B4 or something like that. So that's on the shield. So let's talk about the sensors that I'm going to use. I'm going to use this one. This is a little GPS module from Adafruit. It's a very nice GPS module. It's the Ultimate GPS module revision 3. And yeah, it's got a little fixed LED, very nice cheap GPS antenna on there. And there's also a ULF connector. So you can connect it to an external antenna, which I'm actually going to do. Looks like this. Some people refer to that as a GPS mice, but yeah, it has a pretty long cable because normally put on a car or something, but yeah. And if you got a GPS, you're most likely to need a compass as well. This one's from SparkFun. I haven't even unpacked that. It was laying on my desk for I think a year or so, but I just didn't have the time. And this is tilt compressed, so it will notice if it's tilted or something. So this way I just know the orientation of my Rover, so that's pretty handy. And I'm going to use ultrasonic sonar sensors to detect obstacles in my way. So this one is actually mounted. They are very cheap actually. They are. This one's from Arduino. Both are from Arduino, and this one's mounted on a sonar sensor mount from Lynx Motion again. I think the mount is more expensive than the sonar sensor, but anyway. So yeah, you can put this on a server. Server on that could just sweep like this and detect if there's an object in front of it. And I'm also going to use this. This is an inexpensive, simple gas sensor. It's not calibrated, so I can't actually, like, it won't tell you, like, there's, I don't know, 20 BPM of CO2 gas, but it will tell you if there's more or less CO2, for example. So, yeah, that's just kind of like to show what the rover could do. And what I'm also going to do is, on the bottom of the rover, right here, I'm gonna install a color sensor and a line follower. So that's just to help the rover navigate in an area. Like I could put color marks on the floor, or a black line or white line on the floor, so the rover can navigate more easily. So well, the rover also has a camera on board. So this is going to be the camera that's going to be on board of the rover. It's just a simple webcam I duct taped to a fisheye. It just gives me a better field of view. And this is actually connected to a BeagleBone. This one is the older BeagleBone. It's the white version, as you can see. It's the revision 6, I believe. Again, I bought this from Adafruit, and it's also, as you can see, in the Adafruit enclosure. And yeah, so what I have running on there is an image from the OpenRV guys. I just came across them on Kickstarter, and basically what they did is they built a project called OpenRV. It's basically a little submarine that you can control from your computer with a camera on there, so to do scientific research and stuff. And they used BeagleBone and this camera to get pictures to the over a two-wire-based Ethernet cable to the laptop. So I'm using their software, and since it's open source, I can do that. So thanks to the guys from OpenRV. Definitely check out their website. The link is down below in the video description. So it's basically just kind of like an IP camera, but it also enables me to control the rover over a normal laptop, because I can just use the arrow keys. And what's going to be the remote? Well, the remote can either be an iPhone, but that has to be, yeah, an iPhone, a laptop, or this case. It's just basically like a little case I got here, and in there I'm going to build a pretty nice remote actually. So in the end it will be kind of like a laptop, because I'm going to be using this. This is an BeagleBone Black. I can just really quickly disconnect this here. As you might know, it's the newer version of the BeagleBone. It's even cheaper and got a little more features. You don't have to use the SD card anymore. You can if you like. There's an HDMI out, and it just has more memory and graphics. And it's a little bit faster. So very nice board, again, from Adafruit, and in the enclosure from Adafruit. So this is going to sit in the blue case, in the blue suitcase, and it's basically the brain of the remote control. And connected to that, I'm going to have this. This is basically a flat screen. Again, it's from Adafruit. Very nice 10-inch screen, and that's connected over HDMI to the BeagleBone Black, and that's going to show me all the images from the rover. And maybe I could actually use the OpenRV cockpit. It's a software the guys from OpenRV wrote. Maybe I'm just using the normal video image and put a processing program on there, so I can have my own graphics and stuff. So yeah, so this brings me to the communication. How am I going to communicate between the remote and the rover? Well, I'm going to be using XP modules. You might have come across these ones before. They are very nice modules that are creating their own mesh network. And yeah, so these ones are sending at the frequency of 2.4 gigahertz. And they have a range for about 1.6 kilometers, which is actually quite far. And you can actually see, well, I think I've got, yeah, here. This one is a cheap one. This is the Series 1. You can see the wire antenna on there. And as you can notice, this one doesn't have the wire antenna. You can get these with chip antennas, but this one just has, since it's, the range is so great, it has this ULF connector. And I got a cable for that to connect to one of these. This is basically, you might have seen this before, it's a 2.4 gigahertz antenna. You might know them from your router because they use the same antennas. And yeah, so that's going to give me quite a nice range. Much better than the simpler and cheaper modules here. They just have like a range of, I think, 100 meters probably. So this actually is just the XP module itself. And the ones I got here are sitting on an adapter from Adafruit again. Very nice adapter from Radiator. Yeah, so that takes care of all the level shifting and the power and stuff. So they're very nice and very easy to use. Actually, there's one downside of this adapter, because when the adapter was made, these Pro series XPs didn't exist. And these ones are using more power than the smaller ones were. So I will have to use another regulator. Like this one, this is a 3.3 volt regulator, and it just can supply more power than the little ones on here. Yeah, so I just gonna, you can actually, I'm gonna take them off, and there's a 3.3 line on here, so I will just run power into them. But yeah, so then they're gonna be working fine. So on the Rover, as I said before, it's going to be one of these antennas for the XP, and on the remote, on the suitcase, going to be one as well. But obviously, the BeagleBone Black and the other BeagleBone, they have to communicate with each other. So that's going to go over Wi-Fi. So the BeagleBone, the white BeagleBone, on the Rover, this one here. This is going to have this little guy on there. It's basically a little Wi-Fi dongle. It's just like USB. This one. And this allows the BeagleBone to actually connect to Wi-Fi network. You will notice there's a RP-SMA connector on there, and that can connect again to one of these, the 2.4 gigahertz antennas. I'm actually going to use one with a cable, so I can like mount this anywhere on the Rover. And yeah, on the other side, the BeagleBone Black is not going to have one of these, since it's in the suitcase, and I got a little more space there. And you can't actually, I couldn't just go with two of these to connect together, because they both have to connect to a Wi-Fi network. So get this, the remote's actually going to create its own Wi-Fi network, so the Rover can connect to that. So I could even have multiple rovers connecting to the same Wi-Fi network of the same remote. And I'm going to do this with this. This is pretty simple actually, it's just a Wi-Fi router. So this is a pretty cheap Wi-Fi router I found on the internet with, again, RP-SMA connector for another 2.4 gigahertz antenna. And I'm going to put a cable on there as well. So the BeagleBone Black is just going to connect to this one over Ethernet, a very short Ethernet cable. And then there's another antenna going to be on the remote unit. So I got a suitcase with two antennas and a Rover with another two antennas, one for the XP and one for the Wi-Fi. They are both 2.4 gigahertz. And well, wait, there's also another antenna on the Rover, because I got the GSM module, and that obviously has another connector. This one's just an SMA connector, and that's gonna have this antenna. This is a 90 megahertz antenna, and that's gonna be on the Rover as well, since the GSM shield needs that. yeah, so how am I going to control the robot over the remote control? Well, I am going to put a simple joystick in there, but I'm also going to put this in there. This is the receiver of, well, this is the receiver. You might have actually recognized the format of PS2 style gamepad that I got from Amazon. Pretty cheap, I think it's like 10 bucks or something. And yeah, so this wireless has like a range of like 10 meters probably, and that's going to connect to the remote, like the blue case, and then that's sending all the controls over the XB over a range of even 1.6 kilometers to the rover. Yeah, so let's wrap this up with just this one. This is basically just an LCD screen. It's an RGB LCD screen that's going to be on the rover as well, just to show, well, the data of the sensors and stuff. Again, it's from Adafruit, and on the back here I got the LCD backpack from Adafruit as well. And this allows me to actually drive the LCD with just 2 wires over I2C. Well, obviously I need power and ground. And since it's an RGB LCD with an RGB backlight, I will have to obviously control the RGB backlight. Okay, so another word on the construction of the rover. This is obviously going to be the bottom section with the wheels on there, and there's going to be a top section which is going to contain all the electronics, and the 2 sections are basically connected through this ribbon cable, where I'm going to use a connector like this. This is going to sit on the top plate of the rover, and I can just connect to that. And there are also going to be connections for the batteries, since the batteries are in here and I still want to recharge them and stuff. So there are going to be connectors to the top section with power, and connectors with the connectors to, well, they're going to be connectors to recharge the batteries. So all the electronics are going to sit in a box on the top of the rover, and on top of that it's going to sit something like this. So it's going to be like here, and the sonar sensor is going to be on here, and the camera is on top of that. And yeah, so that's pretty much it. Well, there's one last thing. I am actually going to use LED strips like this on the rover itself. Get those to focus. Yeah, LED strips like this on the rover, just yeah, to get a better visual on that. And it's RGB, so I can have different colors, so I can see what state it's in. So I hope you enjoyed the video. If you like my project, show me by liking this video, or if you have a question, ask in the comment sections down below, and subscribe for more videos. Thank you.